Studies disagree. By how much? 5 studies tested the same treatment, and they got 5 different effect sizes. So how much do they really disagree? That's what tau squared measures. How much the true effects vary from study to study. Here's a meta-analysis. 5 clinical trials, same treatment. Some effects are strong, some are weak. When we pool them, we get 0.30. But how spread out are the true effects behind that average? Now you might already know I-squared. It says 46% of the variation is real, not just noise. But that's a percentage. It's relative. Tau squared goes further. It gives you the actual variance, 0.012, and it's on the same scale as the effect size itself. So I-squared tells you how much of the spread is real. Tau squared tells you how far apart the studies actually are. Here's another way to think about it. I-squared says 46% of the disagreement is real. Tau squared says the true effects scatter by about plus or minus 0.11 around the mean. One gives you the proportion, the other gives you the distance. The formula. You take Cochrane's Q, subtract the degrees of freedom, and divide by a scaling constant called C. So 7.45 minus 4 over 289. That gives us tau squared equals 0.012. And if we take the square root, tau equals 0.109. That's directly comparable to Cohen's d. So what does this actually mean? If a brand new study ran tomorrow, where would its true effect land? The 95% prediction interval goes from 0.085 to 0.513. So the effect is always positive. That's good. But it could be anywhere from small to fairly large, depending on the context. How to interpret it? When tau squared is near 0, the studies basically agree. When it's small, there's mild spread, but the pooled estimate is still useful. When it's large, the studies are telling very different stories, and you need to figure out why. Ours is 0.012. That's mild heterogeneity. The pooled estimate is still meaningful. When to use it? Always report tau squared alongside I-squared in random effects models. Use it to build prediction intervals. And when it's large, run meta-regression to find out what's driving the differences. And always pair it with I-squared and a forest plot. Try it free at MetricGate.com.